All right, so in 6.5, we are working with radicals. Yesterday we did some simplifying like we did in 6.3. Today we're going to add, subtract, and multiply. And then we're also going to be using conjugates to rationalize the denominator. So we haven't added radicals yet. So let's go over the rules for adding them together. So the radicals have to be like terms. When it is a radical, the like term means that you have the same index number and the same radicand. Okay, so they are like terms when they have the same index and the same radicand, which we reminded ourselves yesterday is that value underneath. Okay, so those are the two things that have to be the same. Okay, that's what it means to be like terms when you are a radical. You also must simplify radicals to see if they are like terms, because sometimes they might not look like it right away, but then when you simplify, when you take out those perfect values, okay, you can add them together. So we're going to do a few quick examples of those. So the first one, we have 3 root 2 plus 7 root 2. Yeah, 3 root 2 plus 7 root 2. Okay, so we do have the same index. The index is 2, the radicand is 2. When that happens, you can treat this just like a variable. Because if this was 3x plus 7x, it would be 10x. In this case, instead of x, we have root 2. So this is just going to be 10 root 2. Okay, if they are like terms, you would just add the values in front. All right, so based on that, I want you to try number 2. So we have the cube root of x plus 2 cube root of x. Okay, the cube root of x plus 2 cube root of x. Okay, so the first thing you want to ask yourself, are these like terms? Do you have the same number underneath the radical? Yes, okay. Do you have the same index number? Yeah, so then we have to add the numbers in front. Now, one of them, you can see the number in front is 2. What's the number in front of the cube root of x? 1. So when you add them together, you have to make sure that you include that 1. Okay, or else you would be multiplying. So if you just left it as 2, that would be a multiplication. Okay, so you do have that understood 1 here. Okay, which means you're going to have 3 cube root of x as your final answer. All right, and then the last one we're going to do is the square root of 12 minus the square root of 3. So upon first glance, it looks like these are not like terms, but we've been simplifying radicals for a long time. Okay, so I want you to simplify what you can. Okay, so simplify your radical. All right, and then tell me what you're thinking about with this one. What can we simplify, the root 12 or the root 3? What do you think? 12. Yep, the 12. So when you're simplifying, what does that mean you're looking for in 12? Yeah, you can do the factor tree. Okay, when you're doing the factor tree, you can think about your perfect squares, or you just know if there's a group of 2, that's going to come out. So you have 2 root 3 minus root 3. Again, pay attention to the numbers in front. Okay, so if it's just minus root 3, remember there's a 1 there. So 2 minus 1 is going to be 1. 1 root 3, we're just going to write that as root 3. Okay, and if you don't want to do your factor tree for 12, you can also just simplify using your perfect square. 4 times 3 is 12. Square root of 4 is 2. Okay, either one of those are fine. Okay, so we are going to be doing a lot of simplifying like this, okay? All right, so let's get this party started. You guys ready for this? I'll have to play you guys this song. When Miss Whipple was in high school, we had these CDs called Jock Jams. They would like play them before basketball games. The players hyped up.
They called what?
Jock Jams. You know, like you're a jock, I guess you can. Okay, so the best thing to do when you have multiple things you have to simplify is let's just do one at a time. Okay, so you can do whatever you are more comfortable with. You can factor tree if you want a factor tree. Okay, you can pick out those perfect squares if you want to pick out the perfect square. Something like 45, right away we know that's root 9 times root 5, right? 9 times 5 is 45. Okay, so that becomes 3 root 5. Now notice that you still have this 2 in front. Based on what we did yesterday, do you guys remember how you can simplify this? Yeah, you're going to multiply the 2 by the 3 to get 6. So you're going to have 6 root 5. Okay, I'm going to give you a moment to simplify the next 2, and then we'll go over our final answer together, okay? So I want you to go ahead and simplify 48. You can factor tree, you can pick out the perfect square. Good, you guys are doing a really nice job. Okay, so for 48, the biggest perfect square that's in there is 16. Okay, if you know that, you can take that out right away. If you're like, oh, that's kind of bigger than I'd like to think about, yes, you can do the factor tree. Okay, so if you have a group of 2, it comes out. If you have 2 groups of 2, you have to multiply them together. Okay, so 2 times 2 is going to be 4, so this is going to be 4 root 3. Okay, and we just simplified root 12, so we know that this is going to be 2 root 3. All right, so then when that happens, you're just going to multiply those outside values together. Okay, and then Kobe, what'd you do next after you got all those simplified? Good, and that gave you? Good. Okay, so when you combine those, you get negative 2 root 3. You still have this 6 root 5 in front, and you can't combine these because you have different radicands. Okay, so this is your final answer. Okay, and I saw several of you get there. That was great. Okay, knowing that you can't add those together. All right, so now we're going to look at an example that also has a variable in it. So we have the square root of 135 plus 5, square root of 10d minus 3 root 60. All right, so when you have these larger numbers, that factor tree is going to be helpful. Okay, 135 is not even. Okay, and then you can see if 3 goes in there. Do you guys remember how to tell if 3 goes in there right away? Just add the digits. So 1 plus 3 is 4. 4 plus 5 is 9. Does 3 go into 9? Yep, so then it will go into 135. Okay, so you can divide it by 3. What's another number you know goes in there? 5, because it ends in a 5. So you can use those divisibility rules. Okay, so 5 goes into 13 how many times? Twice, because you get 10, right? 5 times 2 is 10. Okay, 13 minus 10 is 3. So how many times does it go into 35? 7 times. Okay, you can also set up your long division, that's fine. Okay, and then this would be 3 and 9, which would be 3 and 3. Again, we're working with a square root. So anytime there's a group of 2, okay, one of them comes out because this is 3 squared. When you take the square root of 3 squared, you get 3. Whatever's left inside, this time we have 2 factors left inside, we multiply those together. Okay, whatever's left, you're going to multiply. Okay, now with this one, with 10, when you simplify 10, it's just 2 times 5. There's nothing that's going to simplify there. And then with this variable, you only have one of them. You need 2 in order to bring anything outside. Okay, so this is just going to stay. Okay, and when you do your factor tree, you can use any values you want, any product. The reason why I like the 2 is I think it's easier for me to see what I have left. Okay, so this would be 2 root 15, but then don't forget you have this negative 3 on the outside. So if you have 2 values on the outside, you're going to multiply those together. Okay, and then if they have anything in common, we're going to combine those like terms. So I have 3 root 15 and negative 6 root 15. Generally, if you do have a negative, that's going to go second. So I would write my answer is 5 square root of 10d minus 3 root 15. Again, just make sure that if it's underneath the radical, okay, that you've written it underneath the radical there. All right, and then for part C, we have 10 square root of 175a minus 4, 112a minus 2 square root of 63a. All right, so why don't you start by doing the factor tree for the first one. So you can simplify that down. And then you can move your way through those just one by one. All right, so for 175, when you're doing your factor tree, hopefully you split it up with 5. You know 5 goes in there, so 5 and 35, which is going to be 5 and 7. Okay, I like to write this out first as 5 square root of 7a. Okay, so I can see what I'm multiplying together. So for the first one, I have 50 square root of 7a. Okay, thumbs up if you got that one. All right, and then the next one was 112. So anytime it's even, I'll break it up with a 2, and I'll keep doing that until I can't do it anymore. So 2 and 28, 2 and 14, 2 and 7, one group of 2, two groups of 2. So this would be -4 in front. 2 times 2 is 4, root 7a. Okay, so I have minus 16 square root of 7a. Rocco, knock it off. Okay, and then for this one, with 63, I would just do the perfect square because you know that this is root 9 times root 7. Okay, so this is -2 times 3 square root of 7a. If no perfect square goes in there, like one of your rules, I do think that's a little bit quicker. And then all of these have the same radicand and the same index. So we can just add those values in front, which is what we're going to do. Okay, so we have 50 minus 16 minus 6. Sometimes I'll actually combine these together first. Okay, like this is -22. 50 minus 22 is going to be 28. And then square root of 7a. Or actually be easier in your head to do negative. Oh yeah, big old negative, never mind. All right. Now we are going to multiply. So we said we were going to add, subtract, and multiply radicals today. So we just did some adding and subtracting. Now we're going to multiply. Okay, I actually think these can be kind of fun. So we're going to use FOIL. Okay, so sometimes when you see something for the first time, it looks a little overwhelming. So we have 12 root 10 minus 6 root 5, and then 12 root 10 plus 6 root 5. So this is a binomial times a binomial, so we are going to FOIL. All right, so then let's multiply the first one by the first one here. So 12 root 10 times 12 root 10. When you are multiplying, you're going to multiply the number on the outside by the number on the outside. So 12 times 12 is 144. Okay, and then when you multiply the square root by the square root, what's the square root of 10 times the square root of 10? 10. So remember our smiley faces from earlier? Okay, same thing. So 144 times 10 is just going to be 1,440. Okay, now in the inside here, you have -6 times 12, so you have -72 on the outside. If they're not the same, you just multiply them underneath. So it's -72 root 50. And I like to do the inside first. You guys can do the outside first if you want. Okay, and then 12 times 6 root 5. 12 times 6 is 72. It's going to be positive. Root 10 times root 5 is the square root of 50. Okay, so what's going to happen here? You have -72 root 50 and plus 72 root 50. What does that make? 0. Okay, and then the last one, you're going to have a negative times a positive, so this is going to be minus. I'm just going to write it up here. So -6 times 6 is -36. Root 5 times root 5 is 5. Okay, so we're going to multiply these together and then subtract. Okay, when you're multiplying these, you can either set it up 36 times 5, or sometimes what I like to do is 30 times 5. 30 times 5 is 150. 6 times 5 is 30. Together it's 180. So whichever way you want to do that is fine. Okay, so you have 1440 minus 180. Okay, so 0 minus 0, you can borrow. Okay, so that's going to be your final answer, 1,260. Okay, so with these, you may or may not have noticed that they're conjugates. Okay, whenever you multiply your conjugates together, you should get a whole number. If you multiply conjugates, the middles cancel out. Okay, so that's a pattern that you will see. All right, let's multiply two things that are not conjugates. So we have 7 root 2 minus 3 root 3 times 4 root 6 plus 3 root 12. Okay, now you have a couple options here. You can either simplify now or you can simplify later. Okay, I like to simplify at the end so that I don't have to simplify twice. So sometimes if you simplify now, once you multiply, you're going to have to simplify after that as well. Okay, I like to think of it all at one time, so I start by using FOIL. Okay, so when you multiply here, I want you guys to write down what you get. Okay, you can just write down the unsimplified version. Okay, but see if you can do the FOIL. All right, and then Carson, what'd you get when you did 7 root 2 times 4 root 6?
28 root 12.
Great. All right, and then Ryan, will you tell me what you got when you did these two together?
12 root 18.
Yep, make sure you have the negative on there, so negative 12 root 18. Okay, and then Abigail, what'd you get when you did 7 root 2 times 3 root 12?
21 root 20.
Great. All right, and then Ian, what'd you get for the last one?
I'm doing it right now.
Okay, whenever you got it, you can give it to me.
Negative 9.
Mm-hmm.
36.
Great. Okay, nice work, you guys. So now we're going to go through and we are going to simplify whatever we can. Okay, so in the square root of 12, we've seen that a few times today. It's just going to be 2 root 3. Okay, so then we're going to multiply 28 times 2. So we can just double it and we get 56 root 3. Okay, for 18, the perfect square is 9. So the square root of 9 is 3. So you're going to have 3 root 2. Okay, I'm going to give you another moment now to simplify and write out what those are simplified, okay? All right, so you have negative 36 root 2. Okay, and then Will, how'd you simplify this next one here?
Yeah, 42 root 6.
Okay, so tell me what root 24 was.
2 root 6.
Yep. Okay, so the perfect square is 4, then you multiply to get 42 root 6. Okay, nice. And then the square root of 36 is just 6, right? So you guys have negative 54 minus. Okay, now if you go through, you have root 3, root 2, and root 6. None of those are like terms. Okay, so this is going to be your final answer. Okay, so that's, I know that's a different looking answer than we're used to, but that is perfectly fine. Okay, so if you have no like terms, you can just keep it in your FOILed order. Okay, so I technically use FEAL because I like to do the inside and then the outside. So if you have these two flipped around, that's not a problem. Okay, so whatever order you FOILed in, that's what you're going to keep it in, okay? All right, and then the last thing we're going to do today is multiply by the conjugate so that we can rationalize the denominator. Okay, so when we are simplifying, for the first one we have 7x over 3 minus root 2. Okay, so our goal is to eliminate the radical. Okay. Okay, so to eliminate the radical in the denominator, I did not even spell eliminate right. Put element. Eliminate. There we go. Looks like climate. To eliminate the radical in the denominator, you're going to multiply by the conjugate. Okay, how many of you remember what the conjugate is? Oh, none of you? Okay, yeah, Rocco, what is it? What are we going to multiply by? Okay, so tell me what it is. Great. So we're going to multiply both of them by 3 plus root 2. You also have to make sure that you're multiplying both of them because it's okay if you multiply something by 1. If you multiply by 1, nothing's going to change. Okay? Now, in the denominator, you are going to FOIL. So let's think about what's happening here. If you do 3 times 3, you get 9. Okay? When you do the inside, you have negative 3 root 2. On the outside is positive 3 root 2. The reason why you multiply by the conjugate is that so that those are opposites and they make 0. So when that happens, okay, I'm not even going to write those down there. That's just going to make 0. Okay? And then negative root 2 times root 2 is just going to be negative 2. If you multiply by the conjugate, this should always be a minus. And then I always just put 7 on the bottom. All right, now on this one, you are going to have to distribute. So 7x times 3 is 21x. 7x times root 2 is just 7x root 2. So what we're going to do now is we're going to divide both of those by 7. So if you have 21x plus 7x root 2, okay, you can simplify these by separating them. See if you can write what your simplified answer is without me telling you. so 21 divided by 7 is 3, so this is 3x. Here the 7's will cancel, so it's just x root 2. Okay, and this is your final answer. That's how you're going to leave it. Okay, you can't combine those because they're not like terms. This one has a root, this one does not. All right, I want you to give the next one a try. So at the very least, you can write out what you're multiplying by. All right, so Haley, what did you multiply by for this one? And then, yep, so when you multiply, keep this one positive. So you can do 4 root 5 plus 4. You don't have to make both of them negative. Just like here, if it's positive, you can keep it. Okay, and then we're going to FOIL. Okay, so 4 times 4 is going to be 16. Root 5 times root 5 is going to be 5. And then the middle and the outside will cancel. So then all you have to worry about is this minus 16. Okay, so 16 times 5 is 80. So you can do that here, the 80 minus 16 to get 64. Okay, that's fine. And then in the next step, you can put 64 in the denominator. Okay, and then here, when you're distributing, 4 root 5 times root 2 is going to be 4 square root of 10. Root 2 times root 5 is root 10. This is like a 4 times a 1 on the outside. And then you have 4 root 2. Okay, now just like we did last time, we are going to simplify here. Okay, so you have 4 root 10 over 64 plus 4 root 2 over 64. If you have things on the outside, that is the only thing that you can simplify here. You can't simplify anything in the radical. Okay, so you have 4 over 64. Okay, how do we want to do this? How do we want to simplify that? Okay, so you can divide them both by 4. So 4 goes into itself 1 time, goes into 64 16 times. You can also just cut it in half twice. You get the same thing, right? And then this would be 1 over 16 as well. So you have root 10 over 16 plus root 2 over 16. Okay, and then if you want to write this as 1, that would be fine as well. Like you could write root 10 plus root 2 over 16. Okay, that would be correct. Okay, but you do need to make sure that you reduce it. Okay. All right. This is the last type that you will see. Okay, notice now we have radicals in the numerator and denominator, and they're both binomials. Okay, so I want you to write down what you're going to multiply the numerator and the denominator by. All right, and then Caroline, what did you decide to multiply by for this one? That it's just going to be root 3 minus root 5. That's good. Okay, so whenever you're multiplying by the conjugate, if you have two radicals, that can be kind of tricky. All you have to do is change the sign in the middle. Okay, that's all you need in order to get your cancellations. Okay, so here we're going to FOIL in the denominator. Okay, so when you FOIL those together, root 3 times root 3 is 3, yeah. And then this would be root 15 and minus root 15, those would cancel. And then you'd have minus 5. Okay, so this is going to end up being negative 2 in the denominator. Okay, and now we're going to FOIL the numerator. Okay, so I'm going to give you a moment to do that. So this is going to be like what we did on the first page. Okay, so just focus on the numerator times the numerator. Okay, so make sure you FOIL, you're doing first times first, inner, outer, last, and then go ahead and combine your like terms. Okay, so for the first one, 2 root 3 times 2 root 3. Sometimes what I do is I just write down the 2 times 3. Okay, if I feel like I'm doing too much in my head, then I'll just write the simplified version above it. And then I have plus root 15 from the inside, 5, 3. Here I have a negative. These are not conjugates, so they're not going to cancel, right? So I have negative 2 root 15. And then here I have minus 5. Okay, so when I combine my like terms, I have 6 minus 5. That's going to give me 1. I remember there's a 1 in front of root 15, so 1 minus 2 is negative 1 root 15. I'm going to change that in a second. And then we're just going to divide both of these by negative 2. So when you simplify that, you just have negative 1/2. A negative divided by a negative is a positive. And if you have a 1 in front of a root, you don't have to write it. It's not wrong if you do write it, so it's okay if you did. Okay, but this would be your simplified version, or if you wanted to write it like this, you could do that as well. Okay? All right, I'm going to give you the next 15 minutes to start on your assignment.